Thank you so much. Welcome, everybody. It's a pleasure to be back once again. So we continue from where we paused last week. I would like to do a quick recap of what we went through last week. We established last week that, artificial intelligence is not rocket science. It is just a way. Okay. Okay, right. So I was asked to just fire on that. Everybody remembers what we talked about last week, So I guess that's good. All right. So we established that everything starts with numbers and ends with numbers in artificial intelligence. And what we try to do is to compress information that we extract from reality into numbers. We find a way to turn them to numbers, right? We find a way to turn all those things to numbers and, run some other numbers, which we'll be going through today together. What does this number look like? What are these numbers? How does it get the numbers, right? So we established that, okay, start with numbers, and then after training, the model ends up with, some other numbers. The training process gets the numbers to be tuned in a particular way, such that during time that inference time is what we call it, right? Time that you want to use the model, then it recompetes the number right back, and then it can give you some meaningful, data like video, images, or words, right? So that's essentially how AI systems work, right? So we're at audio processing. You have a question? Oh, okay. All right. So on audio processing, what we do on audio processing is that we use what we call frequency mapping. We extract the frequency information. It's easy to extract frequency information per time. It's instantaneous, data. As I'm speaking right now, hello, my name is Oyinlola Israel. That took a couple of seconds, right? But that length of 5 seconds contains some data. And for images, said okay, it's pixel that contains the highest amount of information about what is inside that image, right? For video, it is arrays of those pixels, right? For what else? For audio, it is frequency. Sorry, it's frequency. Sorry? Yes, exactly. So how do we extract that information? Because everything at all that we want to train, whatever data you collect, you have to find a way to massage it into a number. And that number that you are getting is an approximation of information contained in that data. And you need to be able to do it such that you can reconstruct the information back from numbers. For images, when we convert images to numbers, we can always reconstruct it back to image, right? We'll go through that today as well. For audio, when we convert audio to numbers, we should also be able to reconstruct the audio back from the numbers. So it's those numbers, but by the time we decompose the audio information, we get the numbers. That is what we use to train the AI system, right? And that deconstruction process, for image is very simple. You just go through pixel by pixel. You'll be extracting the R value, the red value, the green value, and the blue value, right? Inside each pixel across all the screen. That's what you do for images. But for audio, what you do is to do something that we call sampling. So every millisecond is too much. Every nanosecond, something like that, we will take a sample. What is the frequency number at this point in time? And then we do that. So in single 1 second, we will take that sample about 12,000 times. There's different people, different AI architects. There's actually a discipline like that, right? Those are the people that decide, okay, what numbers do we use? I can I can decide to sample at 6,000 times per second. I can decide to sample at 240,000 times per second. I can decide to sample at 12,000 times per second. But, you know, that number is decided by the application of what you're trying to do with the AI, right? So there are people like AI architects that will now say that, you know what, if we sample at 240,000 times per second, that will be too much, because that means you have, for every second, you have 240,000 numbers. Right? That's incredible amount of storage, processing, and all of that. It will take so much time to train. But like, for the application that we're trying to do, it's okay to just do 12,400 or 24,000 sampling rates. But what essentially happens is that whatever number it is, what happens is that we take the frequency information of that voice, because as my voice, as my voice is coming out, it has this frequency information in it, right? And that's the only thing that can tell us about the content of, at least, to humans, we need to appreciate that, the power of our brains. We really need to appreciate it, because it seems so natural, like, well, how would you do it to a computer? For computers is to essentially extract that frequency data across time, and then we keep doing it every second. So you see that a 10 minutes audio that we're doing sampling at 12,000 times per second, we have 12,000 times 60 times 10 amount of numbers in it. That's already, crazy. That's why AI needs, some serious heavy computing. Right? You hear Sam Altman, that's the CEO of OpenAI, saying that we need $7 trillion to be able to do AI the right way. The guy wants to, build some really interesting things, right? He really thorough AI that can change content words. If you ask it to create a movie scene by just describing what you want, to create a movie scene, right? So that guy is crunching billions of numbers per second, right? And also remember what we said, that you can deconstruct, media information and reconstruct it back. All of that video that you guys are watching is just some numbers at the end of the day, right? So, but it's kind of like complex in structure. We can, if time allows us, we get there actually. Yeah. So here I said pixel, as pixel is to color, as pixel color are to images, so are frequencies to audio. Right? So we convert audio to numbers by breaking a long audio recording into short time steps, very short time steps. And then we count the frequencies within the audio. We just measure the frequency within each time step. And then that's how we get the numbers. Please move to the next one. Okay, this is very, very interesting. I will touch on this on the next slide, the slide that I prepared for today's topic. How is AI, the very interesting question to ask is, how is this AI thing working? How is it working? Okay, we've converted all these things to numbers. Images, we've converted it to numbers. Audio, we've converted it to numbers. Text, we've converted it to numbers. So, and then what? And then what? How is it working? Like, how is it able to tell me? We're going to do some interesting demo. We can take a picture here, and then ask the AI to describe what it's seeing. And it will describe it to us. It will describe it to us like, okay, this is a bookshelf, with a monitor and then a table. And look, it will describe it to us. But how? Okay, you trained it by decomposing the data that you use to numbers, and then after training it, how then is it working? So this is an analogy of how it works. This is an analogy of how it works. Who knows the game of charity? It's a popular game, or maybe not so popular, because I've seen a lot of people play the game lately. Who knows that game? Anybody? So how to play the game of charade is that I'll be, let's do an example. I could say, there's a box. I'll pick a slip of paper. I'll pick a slip of paper that has something on it. I cannot tell you what is on that paper, but I can tell you everything else for what is on that paper. And then you have to guess what is on that paper. Well, so this is the digital version of that game. So this is the person that has, is showing the word like, okay, this is the word. You cannot mention this word. You can mention anything else but that word, but what you are mentioning must lead me to what that word is on the phone. So there's a game. If you go to Play Store and App Store, you will see that app. If just type, if you type charade there, you will see a lot of apps like that. So by the time you open the app, it will come up with a word. So for example, if I want to play the game with you guys, I'll just, once I open the app, I'll put a phone like this. So it will show you guys the word. And all you have to do is to lead me to the word it's showing without telling me the word. Right? So if it is showing Messi, Lionel Messi, what would you tell me that will lead me to Lionel Messi? Okay, footballer. But we have hundreds of thousands of footballers. What else would you tell me? Okay, it's club. There are probably 20 other people playing for that club. What else would you tell me? Okay, there are about 5 people that have won Ballon d'Or. What else would you tell me? Okay, by the time you tell me the country, I would have probably been able to narrow down, to the right answer. So that's like five information. So you keep narrowing down, right? Till you lead me to the right answer. So you can do that for, if I say, okay, you could do it for any other word. Maybe it's a house. You can say place where people live. Well, that's too easy. That's really too easy. But try the game. It's very interesting. You let it up. So that's how AI systems work. What you are training the AI with, that's really the reason why it has to have predictive information about the target outcome. What you are doing when you are training is that you are nudging the AI model to the right answer. There's a slide I prepared for something like that. You're nudging it, and we'll see how it learns shortly. The numbers, it will be changing the numbers, right? You're fed with some numbers, it's trying to get to some other numbers that will now represent, the information, such that you can ask it new information and it can respond. That's the idea. I don't know if I've lost anybody, right? So that's the idea. So during training, you are nudging the numbers. Would see an example of that real life of how those numbers are changing during training process. So yeah, it's as simple as that. So when you are developing an AI system, it's very, very important. There are complex. What we'll talk about here is simply, the basic information that we train AI with: audio, text, and video. But in industry, information becomes more complex. It becomes more complex. If you need to optimize your supply chain, what information do you go after? We just established that 2 information that you get are not Bonico. They're more superior than each other. So you want to go for high quality superior information that very few, information. There's something called, information gain. But if you tell me out of the five information I just provided to me, there's 1 or maybe 2 that you give me that you wouldn't have to say the other 3. Right? So those are the kind of information that you want to go after. How does YouTube, how does LinkedIn and TikTok know How do they know you to serve you the content that you are likely to, that will hold you, you want to leave that platform? What are the information that they train that model with? There are some of them, like, we won't go too deep into that because we're not trying to decompose their AI model. But the AI model is essentially trained with some information. Those information have strong predictive relationship to, retention. So the AI model is carrying retention, because that's the objective. They want to hold you on the platform so that you won't go. Because the more they hold you, the more they make money, right? They serve you ads. So the AI model is carrying retention. Hold these users for as long as possible on the platform. So now there are AI engineers who are now, trying to like, okay, is it the number of likes? Is it number of watch hours? Is it number of scroll per second? Is it, and then by the time they train the AI model, so there's a way to do it systematically, right? That gets you to the, most predictive information. And that's what's called, principal component analysis. We're not going to get to the, say, geeky method. So that if you have 100 information about something, it's just tell you that, see, trash out this 92, just use this 8. Yeah, but you don't, in the beginning, you don't want to trash out anything because you never know. It's at the end of the day that you know that, okay, 92 are useless, right? So that is how AI systems are. You want to use information and data that is highly predictive of the outcome that you are trying to target. And this is so important because in real life, it is beyond voice, it's beyond audio, it's beyond images, it's beyond text. It's beyond that. Like in the example of TikTok and they have to synthesize those information because they are sort of like elusive information, right? The number of likes, what the category of the like, the genre of the like, the location, there are about 72 data points that Facebook's AI model uses about you, 72. And by the time you get all those 72 information and you like a few things, you do a little bit of interaction about those 72 things, they know you. They said they know you more than, by the time you like 5 things on Facebook, they know you more than your friend of 15 years. By the time you like up to 30 things, they know you more than your spouse. By the time you like up to about 50 things, they know you more than your parents. So things that you are thinking, you've not really expressed it. You've not. So people feel like these people are monitoring them. They feel like Google, Facebook, they are monitoring them because you will just be talking about something and then you start seeing it as ads. It's likely they are not actually monitoring your voice. It's because you've done something. You did something actually that suggested the fact that you want to buy a car. You are just talking about, I like Honda cars, man. I love Honda cars. But that is an information domain, audio. But there are other ways that the fact that you like Honda cars will come out, even though you're not voicing it. And those models are able to detect it, and they will serve you as Honda cars here. See Honda cars here. Because they need to do that to make money. They need to do that. So the reason why that is important is because you need to get creative in reality. By the time you're building AI systems, you need to get creative, to determine what information modality to aim for and go after. All right, let's move on to the next screen. Okay, so yeah, here I was just saying that data is everywhere. The world generates about 72 zettabytes every second. You can Google what that means. How many zeros is there? 72 zettabytes every second. The human body alone, at the organ level, generates 2 terabytes of data per day. The human body generates 2 at the organ level. So there is information available at every level, right? We have information at the organ level. We have information at the tissue level. We have information at the cellular level. We have information at the atomic level, right? So as you go deeper, it becomes more complex and expensive to extract the information, right? That is why they will, it's only when people get sick that they will ask, we are going to do tests. All the tests you are doing is they're extracting information at the organ level. So the information they're extracting at the organ level, we tell the doctor, suggest, okay, maybe this is the medication I should recommend, or this is the but imagine how much information will be available at the tissue level. At the organ level, it will be essentially telling the doctor that, okay, a normal liver is supposed to be functioning at 174 grams per centimeter cube, something like that. That's how, if you go to read medical reports, after doing some, that's how they will put the normal range, right? But it's, this guy don't go outside the range, the guy don't go outside the range, so the guy don't normal again. So we need to get him some drugs that will bring him back to the normal range, right? So they are extracting this information at the organ level. And at every second, the organ is producing those data, maybe at this second it's 174 grams per centimeter cube. Next second, it is 182. Next, because as you're living, as you are interacting with the physical world, it is affecting your body at the organ level, right? So this is saying that 2 terabytes of data, that's like two giant hard drive, is available at the organ level per day. We cannot track, but how much it costs to do tests. That's just a couple of seconds. The machines are expensive, but smartwatches are the farthest you have gone in terms of extracting information, right? So this is able to extract information per minute. So I can check my heart rate, I can check my whatever, my blood oxygen level and all of those kind of things, right? But there's a lot of information that it cannot extract. There's a whole lot. How my synapses are firing. That's information at the organ level in the brain, right? How my blood vessels are contracting and expanding during, those are all the point I'm trying to make here is that we can solve all the diseases in the world if we can extract all the information that we need. But ability to extract this information is just the barrier. Ability to extract this information is the barrier. Imagine we already can extract information at the cellular level, but it takes so much preparation. You have to organize the laboratory in a particular way. You have put your microscope in a particular way to extract information at the cellular level. So you can do it on a living organism that is walking around, right? You have to, take a sample, do all of those things, right? If you do blood culture, I think blood culture test takes about 7 days to come out from the laboratory. But now imagine if, in the next 100 years, we can get devices like this that I'm wearing that can extract information per minute at the cellular level. It will be telling you that, this cell, this chemical is supposed to reach this cell by this time, but it didn't reach it. This cell is malfunctioning already. You will have cancer in the next 3 years.
Quantum machine analyzer is very that.
So processing of the information is different from extracting of the information. We are still at the extraction level. So the giant problem that we're facing today is that we have made progress as humanity, but our level of extraction is still far from where it needs to be. We can't get enough information that we need to actually solve the problems that we need to solve, even though we produce 97 zettabytes of data per day. What you're talking about is the ability to process that information, right?
No, if you would handle like this, if you get the information from your organs and give you whether it is good or not.
Okay, maybe I don't know the machine then.
What quantum machine analyzer?
Okay, I don't know about it. It's possible. It's possible.
Hello, Ikeja. Hello, Ikeja. We have time slotted for question and answer. Please, we want our facilitator to get to the end of the slides for today. Please, just hold on. You can write your questions and give it to Mr. Denny. Thank you very much.
Right. So where we are is that if we can extract information that's available at the cellular level. Imagine how much information that we'll be able to predict at the atomic level. You would be a small god. You will be a small god. You will see where the world is going. You will see every little thing, where everything is going, because now you train an AI system on that kind of data. You have a prediction machine for the world, right? So our limitation is the size and quality of data that we have, right? And even though we generate over 97, I moved from Lekki, I passed some direction, right? That's some geometry data. That's geometry data. How the car move, the car position at each point, at each second, right? Maybe it was an elevation, or I was moving down the bridge, or that's some data points. Who says that's not useful? Who says that's not predictive of something that will happen, later in the day, right? Who's to say that? But I mean, all of that data is lost because, of course, I mean, that's too much to even keep, right? So the resolution of data, yeah, that's the word. The resolution, we can collect data to usually try to look for, okay, what is the economic value of this data? What is the economic value of this data? What they do, the reason that Microsoft, Google, and TikTok, all of these guys are successful is that they don't think that way. They collect the data and think of the economic value. So imagine cellular level, before it gets to organ level, that you'll be needing drugs. Before it even gets to tissue level, rather. It is when it gets to organ level that people feel sick. There's a research paper that says that average human has about 100,000 errors in their cell per minute. Like a cell that needs a high amount of oxygen concentration in the blood that's not getting it. A cell that needs higher a level of water in the blood that's not getting it. A cell that is malfunctioning for one reason or another. Of course, you have trillions of cells, so you don't die because just a few 100,000 cells are malfunctioning, right? You don't die. So by the time it gets to tissue level, right, you start feeling, okay, maybe you are low on energy. By the time it gets to organ level, that's where people start to feel sick. But now imagine if you're able to capture that information at cellular level, or even maybe in the next 100 years at the atomic level, because we're made of atoms, right? And so this is the incredible possibility that we have, and it's a blue ocean. It's a white space. Nobody knows how to solve this problem. Some people have been trying to, work on data storage to make sure that we can store, infinite amount of data in this small space and all of that. Maybe by that time we'll be able to do that. But even if you have the data, capacity to process, the biggest amount of data. So data is the starting point. Just collect the data. If you don't know how to convert the data to number yet, just collect it. Just collect it. Just keep the data. Yeah. So please, let's move on quickly. All right. So yeah, I was just saying here that what is an information system? Everything that is happening in the physical world is because of a lot of things that have happened. A lot of information that we failed to capture, or information that we have ignored, or information that we have missed, or information that we don't even have the competence of analyzing. Because nothing just appears and disappears like that. It's a system. Even God that created the world, follows that system. There's a cause and effect. There's a cause and effect, right? So because we don't have infinite amount of processing capacity to process all the data, we need to carefully collect only relevant, data to the subject. And that's the limitation of the modern world that we live in today, right? And the data is relevant when it provides highest information gain about an independent subject. That information gain, I wanted to keep it at right here. That is what makes AI possible. A pixel has the highest information gain on an image data. If frequency has the highest information gain on audio data. For text, the reason why text was the most difficult AI challenge was because it is hard to place that information gain. What is it the word? Is it the length of the word you want to use? Or is it the complexity of the word? So language was one of the most difficult domain, right? And what eventually solved it was that we just assign a number to the word and we'll move on. So even though, because that number is unique to that word, the AI system was still able to find pattern between the linkages of words, right? So that is how we translate, real life information, real life data to information that AI system can process. Let's move on, please. Mr. Lene. Okay. All right. So I have some examples here. If you're trying to predict crop yield, if you're trying to predict, this is a very interesting problem set, right? If you have a big farm, a $10 million farm, or even if it's a small farm, you are interested in the productivity of your farm, right? This is quite small. Sorry about that, right? So if you're interested in crop yield, what data inputs would provide the highest information gain to train your AI model with, right? So you'll be looking at things like weather condition. You'll be looking at things like soil quality, historical crop yield, farming practices, right? Even though all these things, at the end of the day, you must find a way to convert them to numbers, right? And this is why I was saying that, okay, this is a much complex domain because this is the application of AI, right? So what you do to predict crop yield is that if you have data of past 10 years, what crop yield, what is the maize, quantity of maize that was produced per year? You have the amount of rainfall that fell each of those years. You have the quality sample, soil sample for each of the year. You have the, what else? The practice used. So for this kind of data, practice used, how do you convert this number? You just use it as a textual data, right? Maybe you have practice number 1. I don't know agriculture so much, right? Let's say practice 1, practice style 1, practice style 2, practice style 3. You can just assign them a unique number. The AI system will still be able to figure out the pattern between those relationships. And then by the time you are now, in a new year, you want to find out what is the likelihood that I will be able to predict. Oh, sorry. What is the crop yield going to be for this year? You are going to predict that. You just feed the AI system for all this data for last year. And then you tell you, okay, this year you're likely to produce this amount of products. That is how it works. It's really not rocket science, right? It is, but see, by the time we will do one small AI model together, you see how those numbers are, updating, changing, and all that. You see that it's really not rocket science. It is just to be able to sit down and put one-on-one together and solve small problems and scale it. Solve small problem well and scale it. That is really how this system works, right? If you're trying to predict natural disaster, the information that you'll be injecting would look like seismic information, right? Because the earth shakes all the time. If you've been on Third Mainland Bridge, just stay, maybe your car falls on Third Mainland Bridge, just stay on that bridge as cars are passing. You will see how the bridge is actually shaking, right? The bridge is really shaking because it has some rubber stuff under it, right? As it's shaking, it's impacting the earth crust under it as well. The earth still is shaking, even though it's very small, very, very small. So there are seismic devices that can detect those, the size of the shaking. And if the shaking is too much, you can report to, authorities that can take actions, because it can cause problems, right? When earthquake happens because of too much shaking, because earth is moving. The actual land is, crushing against each other. It's kind of like it's not static, right? So when they crush against each other and there's no space anymore, it's when earthquake happens, right? So you can predict all these things. Right? There's a very interesting, if you're a business person, right? You are interested in the customer lifetime value of your customers. customer lifetime value. If you want to predict that, you'll be looking at, information like customer demographics, right? Purchase history, customer interaction, and customer retention, that's normal within your industry, right? To be able to predict the customer lifetime value. You want to know that, okay, this customer that I just acquired, I spent 1 million naira, get marketing to this customer, to reach this customer. Can I make 1 million naira back from this customer? If I will make 1 million naira back from the customer, how long will it take me to make 1 million naira? It will make you to put things in the right way in your business and all of that, right? So that is, how to do that. Fraud prevention, we use this a lot in fintech. When you just pay with your cards, you don't know a lot of interactions that happens. You just say, okay, your transaction is successful. There's a whole lot that happens behind the scenes, right? So for this, it looks at transaction behavior, transaction history, device information. Your device information is sent over the wire to see, patterns, detect whether the transaction that's just about to happen is fraudulent or not. Network patterns to be able to detect that. Also, a recommendation system will take things like, user preferences, viewing history. That's why Google, Facebook, all those guys, they pay billions of dollars to collect this data. There are data brokers. They call them data brokers. All they just do is to, have you seen this thing? Accept cookie, accept cookie, accept cookie. It just started when EU realized that data brokers were selling people's data. Yeah. So if you don't want your data to be sold, say, okay, decline. So people will still sell it even if you decline. But, if they are small guys, EU will not care about them because, it was because Google, Facebook, and all of that. Once they put that cookie on your system, they can track you everywhere you go on that browser. So even if you Google something else, for example, you want to buy on that car. That people think that they actually listen to them. They don't. Most of the time they don't. You would have maybe done something, maybe spent some time on a page that has on that car. You spend a lot of time on the page. This guy is looking too much at this, right? He's probably interested in another car. You just open Instagram, you just start seeing other car everywhere. So they've connected your computer user ID. Each computer has an identifier, connected it to the cookie that they put on your computer, and then your browsing history, your behavior on those websites and all of that, right? So that's how they connect the dots. And that person in a few seconds, all this data has gone. In a few seconds, they retrain their AI model and they know what they want, right? So that's how they do recommendation systems. So this is just a small list, and I want to believe the main goal of this program is to get everybody to think deep about what are the problem sets within your domain, and what are the information that you need to go after. Someone asked a question, okay, if I will need to improve supply chain last week, right? If I need to improve supply chain of my factory, what are the information that I need to get? And that's how I rephrased the question, at least, right? So the information would look like, what is the, forecast, demand forecast, because if you produce, you're FMCG, you produce and, if it's a perishable goods like water needs to be shipped in a couple of weeks, Abby. If you stay in your factory for too long, then you're poisoning the people. So you want to be sure that, okay, you have a very good handle on demand forecasting, and that's another AI part there. So it will tell you that, okay, on Tuesday, don't produce more than 100,000 pieces of this product. Okay, on Thursday, increase it to 140,000. On Friday, make it, so that kind of information. You need that because it's not only on production, it's on production, it's on shipment, it's on, your distributors. Do they have space in their factory, in their warehouse to collect the products? So you want to collect all this information and then use it to train an AI model to get to the answer. So all this information that we're talking about, those are examples of you telling me who Messi is without telling me Messi, without saying the word Messi. So you're leading me to, I have Messi showing on my phone right here, but you're giving me, okay, he's a footballer, he's an Argentine, he's Argentinian. He played in, how many Ballon d'Or has the guy won? Right? 7. Wow, incredible. Okay, 7. He has one, you're giving me those information and then getting me to say, okay, the word is Messi, right? These information are the predictors that you train the model with, that the target objective. So the examples here are special purpose models. What we used to have back in the days are special purpose models. You just build an AI system that tells, okay, buy not special purpose models. Now what we have today are sort of like general purpose models powered by generative AI, and we'll get there in a short while. Please, let's go on quickly. Okay, so I have some more examples of information that's highly predictive of target objective. So there's one for traffic flow, energy consumption, stock price, credit scoring, or even weather prediction, right? So these are the information. So let's move forward real quick. Okay, so yeah, this is where we should have ended last week. So the data you need to achieve your objective or explain any phenomenon is around you. You may simply need to develop an awareness for it so that you can go get the data. So what data do you have? What data do you have access to that can unblock value in AI era? So AI, and this was my answer to some people last week. Okay. Data. Pipe dream, smokes. So if all you have is access to data, my friend, you have you have massive treasure. All you just need to do, hey, you build an AI system. See, I have data here. I won't give you access to the data. I will probably, maybe, find a commercial arrangement because you own the data. Without data, AI is a pipe dream. So you need to be methodical about going after quality data. This is business on its own. There's a company called Scale AI. The founder of that company is the youngest billionaire in the world today. Of course, because it changes, right? At one point, it was Mark Zuckerberg. Mark Zuckerberg is old now. His grandpa now, right? So the youngest billionaire in the world today is the founder of Scale AI, and the guy is not training AI model. He's not learning AI model. All he's doing is giving data to the people that are training AI model. Is giving data. Oh, you want to train an AI system? I have data here. You want data about this thing? Okay, I have data that I will give you. That's massive opportunity here. So if that is what you can do to help Africa, to measure up, it's going to be valuable, incredibly valuable. Incredibly valuable. So you don't have to code. You don't have to be an engineer. If that is all you can do, that will matter enough. Let's go to the next slide, please. The next slide. Okay. All right. So we're still, the entire series is still on introduction. We've not really gone into the technical part, but if you fully understand this part, you will be on your way to figuring out the rest. You will be on your way. So now that you have the data, how does the machine find out the pattern? How does it learn the pattern? So how it finds the pattern is called machine learning. It is through machine learning that it finds the pattern. And the pattern is what helps the machine learning model to be able to do its target objective. And then there are, of course, small mathematics. You'll be surprised at how simple the mathematics are. the mathematics, the machine learning mathematics are so simple. Of course, there are some parts that are, the YDX parts, but the basic part of machine learning, of how AI systems are built, they are so simple. So let's backtrack a little bit. Back in the days, we call ourselves programmers, right? Of course, you say, oh, I don't code. What's my opportunity? What can I do in AI, right? We all recognize that coding is very important to do all these things. Coding is going to be as less important versus 10 years ago. Coding is in the problems and let the AI answer. So by building machines that can learn, we build machines that can mimic human intelligence, which is referred to as AI. Please move on to the next place. So it's fading away. The software we are using today, your browser, someone wrote the program and says that if the use from your mouth, it is procedural program. 10 years time, if that program code doesn't be functioning, so they are defined during the time that you're building the software. That's how they work, right? Traditional programming. If you want to write a function that a program that calculates a mathematical function, right? It will just take the parameter for that function, compute it in a procedural way, step by step, and then return the output. That's how it. Now there's one guy that is capturing that method now, and that's the artificial intelligence using the AI method. So the AI, to do AI, it requires traditional programming. But what you do with traditional programming on AI is different. Instead of writing what you want, in traditional programming, we write what we want the system to do. Go to the web, search, put a list, and then let the respond to the user's click, do this and do that. That's what we do in traditional programming, define specifics. And that's why most software codes are really big. The code for a browser, for example, is over 1 million lines. Because you have to state everything clearly. Like you can, you have to define everything you want, right? Over 1 million lines of code. But in machine learning, I have right. And AI is of code. The whole ChatGPT is a so
Hello, everyone. We apologize for the itch. Ikeja is trying to reconnect. Please bear with us.
Okay. Sorry. Internet seems. All right. Can I get back?
Hello, Israel. You are still breaking. You are still
Correct.
breaking. You are still breaking.
Okay.
Hello, can you confirm if you can hear us?
Yes. We can hear you now. It's a bit better. Israel, can you speak?
We can't hear you.
Can you hear me?
Maybe you should use this.
Can you alternate your network? Keja, do you have a separate network to connect?
We can't hear you. It's like you are muted.
I am not muted. The problem is from you. Josephine, you can hear me, right?
Clearly. I can hear him too.
Yeah, I could hear him, but it was
I can
breaking.
hear you.
Okay. I think the audio is coming. All right. You can hear me as well. All right, great.
Israel, you can hear me?
Awesome. Apologies, everybody. I think the internet here has just been.
Israel, can you hear me?
Messy.
Israel, can you hear me?
Everything is okay? Anthony?
Israel, can you hear me? Israel can't hear me.
I can hear him. I can hear Israel.
I can hear
Israel,
Israel, but
can you
Israel
hear
can't
me?
hear me. There's still a problem there. Ikeja can't hear me.
Is it a system or the internet? Yes. Let me put this.
Sorry, guys. Let's give them more time to sort out some of these tech issues.
No problem.
Okay.
Are we fine now? Hello, please confirm audio.
Israel, yeah, I can hear you, but can you hear me?
Okay,
Yes,
great.
we can.
I can hear you now. Awesome. Okay.
Okay, you can hear me, Israel, clearly.
Yes, clearly now.
Okay, is there a quick question before you continue? Is there a way we can deploy AI to actually handle this issue of this internet connectivity for us? Can you help us with that, please?
Very, very nice one. No. No.
Go ahead with your presentation.
Okay. Well, because it's the domain of the problem, you know, that's a very interesting question, actually. But I think there are simpler ways to solve the problem, you know. There are simpler ways to solve the problem. Yeah, okay, let's go on. Let's move on. Please, please help share. Okay, yeah, so we're just establishing here that traditional programming, you write your instructions exactly as you want it. You know, usually traditional programming languages take millions of lines of code, right? Base one, for example, which is the fintech company that I run, has, you know, close to about 2 million lines over 6 different systems, written over multiple years, because you have to be specific. If anything goes wrong and you're not explicit enough, you know, something bad will happen. Either you lose a customer or transaction will go a wrong way or something. So you have to be explicit. You define everything, right? So that's a challenge there. You know, a browser also, an internet browser, for example, the source code for Chrome is open source. You can go on GitHub and go and check it out. So Chrome has over 1 million lines of code as well, right? But in machine learning, you are writing code, but the codes you write are not, you're not stating the instructions. That's the difference. You are essentially telling the system that, hey, I have data. I have what I want. Help me find the missing link that connects the input and the output. That is the code you're writing. So it's usually very small amount of code, but very, very powerful in terms of outcomes that it creates. Please, next one. Okay, so here is an example, a very interesting example. You want to make roasted chicken, right? Rotisserie chicken, and you have vegetables, seasoning, and all of the things that you rub on the chicken to marinate it properly. And then the chicken itself, the fresh chicken that you just brought out of the freezer. So how do you move from all of that ingredients, the marination, all of that, to the chicken? How do you move from there to the output? In a traditional programming way, you have to state each line, cut the vegetables, season the chicken, perhaps marinate it and put it in the freezer or fridge. Is it fridge or freezer that I put it? The fridge, okay. So that the seasoning will enter very well, Abby. You know, put it in, marinate it for 30 seconds or 30 minutes rather. You know, preheat the oven, cook it in the oven for 30 minutes, you know, add vegetables. That's how you have to state everything. If you miss any step, it's it's a problem. The bad outcomes will happen. And then at the end of the day, you have your rotisserie chicken. But now in machine learning, what you say, well, you're simply writing code that says that, hey, here is seasoning, vegetables, and fresh chicken, and I want this. I want this, chicken. Find out the map. What is that thing that maps this input to the output? And then you figure it out. By the time you figure it out, you will be able to send new inputs, and then it will give you new outputs. So it will figure out how to cook. So instead of sending chicken, you send turkey. Or instead of sending, please give me an example of seasoning powder. Okay, instead of using curry, you use thyme. It will still compute that and then give you a new output because it knows the steps to go through. So what our AI system is doing is finding the mapping, the connection between input and output. So by the time it knows that, send its new data, that's where people get amazed. Like, wow, did they do this? This is too nice. This is too scary. This is too, because it knows the step. You didn't teach it, it figured figure it out by the data that from the data that you give to it, and then, is able to process new inputs based on the steps that's learned. Mr. Denny. Okay. So here we have an example, cause and effect. So the AI system is learning a cause and effect relationship. Here, this is a very complex, fairly complex formula in physics. It's been a couple of years I did physics, but I think I still remember this. So this formula is saying that, okay, the force between two bodies is defined by this formula. It took those scientists, I don't know, God knows how many years it took them to come up with this, relationship. It probably took them, it's probably a professor's lifetime work, to discover this, write a lot of papers to defend that this is true. And then other scientists will come and bash him, say, that's a very interesting word there, So it was probably a scientist's life work to discover that this formula exists. But for a machine learning, all you need to send to the machine learning system is true value of F, and then value of G, M1, M2, and R. If you find out this relationship by itself without you telling it. Right? Also, in the case of Fm equals to Ma, just feed it true value of F, output, and then input M and A. That's in the case of, this is like our example of vegetables, fresh chicken, and all of that. That's the M and A. And then the roasted chicken is the F. So if you find the relationship that connects the two, so that by the time you send it new value of M and A, it will be able to tell you F. If you send the new value of F and A, it will tell you M. If you then send the new value of A and F, it will give you M. But you may not even know this formula. You may not even know the formula, but the AI system will be able to figure it out. And so that is how it works for all problems. So what is happening is that these AI systems they've detected or discovered the formula that defines some of our realities by the data that expresses reality that we are fed to them. So they break everything down. At the end of the day, it's mathematics that's happening, right? We don't know it. The reason why it's so scary, the reason why AI is so scary is that we know that it's running some computations, but we don't know the formula that it's running. That's why it's scary. You hear a lot of people, Elon Musk will say, slow down AI, slow down, pause AI, AI is too scary, AI will be the end of humanity. And all that. It's scary because this guy, you feed it a lot of data, he finds out the formula, you can find out formula for anything. As long as the inputs are predictive, it will find out the formula that connects the two. But you can't tell you that, okay, this is the formula, so that you can go with it. But if you keep using it. So that's why people get scared. Like, okay, if this guy has an edge over us, then we're doomed. We're in trouble. That's why they are really scared. Right? So it is true because for the formula that we know, if we run an AI system with them, we get the same formula that we took manual approach. It took years of experiment in the laboratory. It took a lot of this. We get the same thing. But for him, to just do a small thing and then figure it out. So he can learn so fast. He can figure out relationships. He can learn cause and effects. He can, just fill in the data. That's why it's so troubling. That's why it's so troubling. Please move on. Okay. Yeah. So what machine learning is good for? Okay. So what machine learning is good for? Problem with long list of rules. If I want to say that, okay, write a program for people that write programs on the call, right? If I say write a program that detects character that is on the screen, how will you write a program? If you write C#, JavaScript, Python, where will you start from? It is technically impossible to write a program that will, for example, I write one, and I take a picture of that one, and I write in traditional programming language, Python, C# or whatever, that will now tell me whether this is 1, 2, or 3, or 4. How will you do that? It is technically impossible because it is possible. There's one way that is possible. If it is a computer written, one, it will always be in the particular way. If you use the same font, if you use the same, font size and font style, right? So, and you print it on the paper. If you type one, the one will always come the same way, right? So one way to write the program is that you'll be saying that, okay, if it's black and white, you say if pixel number 1 is equals to white, if pixel number 2 is equals to white, if pixel number 3 is equals to white, and then the pixel where the 1 is written, you now say if they are black. So you have to go through each through. So imagine the 1 is printed on an A4 sheet, and then the A4 sheet contains maybe 10,000 pixels or 500,000 pixels. You have to write if else for 500,000 times. That's how you would have written it traditionally. And by the time you change the font style, don't scatter. Because the 1 will look differently, right? If you have a different style, and your program will break. So it's technically impossible to do, like for a computer to understand vision and say that, okay, this is, my name Israel written here. It is a very complex problem. But in terms of machine learning, it is very, very easy because it is not realistic for you to ask the programmer, we write 500,000 if else, to detect what color is on the, is on each pixel to detect if it's 1. What about other figures? 2, 3, 4, 5, 6, 7. What about other alphabets? And then once you change style, once you change font size, the program breaks. So it's a very difficult problem. The set of rules are too much. Also, in a continuously changing environment, you need machine learning, right? For example, autonomous cars. Every inch of motion that you make, the environment changes. Every inch of motion, every meter that you cover, now there was no gutter in front, now there's gutter. There's no construction happening, there's construction happening now. There was no bridge, 1 minute ago, but now where you are now, there's bridge. So it needs to be able to react. Okay, what do I do? Do I accelerate? Do I brake? Do I turn left? Do I turn right? How much angle do I turn? Very complex problem. How do you write that kind of code? You were to do it traditionally. So even though it's 4 sets of rules, but it's very, very complex 4 sets of rules because it's people that's in the car. You make wrong choice, you cause trouble. So also you can use machine learning is good for discovering large insights. If you want to discover insights in a large set of data, we have massive data, but our biological brain gets tired too easily. We get overwhelmed with information. We get overwhelmed. What we need is the support of this kind of system that don't get overwhelmed with too much information, right? So when information is getting too much, the brain tires out and just wants to focus on something else. You need a break. You need a break. When the head is getting too hot, right? But this is our tool. This is our only card to solve complex problems that we have in the world. Sifting through massive terabytes of data and making real-time decisions. This is the best decision for you to make right now. This is I used to make one joke, like everybody is a millionaire. Everybody is a millionaire. There are decisions that you could have made 10 years ago that could have made you millionaire today. If only you knew. If only you knew. There are places that you could go today that you'll be a millionaire in the next 10 years. But do you have that information? Do you have that information? There's someone that you need to talk to. There's a relationship that you need to create. There's a whatever. So everybody's a millionaire, even possibly a billionaire. There's something that you need to do. But we don't have that information. That data is there. Is the information we don't have. That data is there. The data is probably even looking at us. Like this, you see me? You really want me. You want me so badly. You want me so badly. Yeah. The data is there, but there is information of what puts that thing together is what. So, machine learning is good for sifting through data. And the reason why that's so is because, it's just because of how biological brain functions. Biological brain functions like firing synapses. When those things fire too much, it wears out the body. You will see some geniuses. When their brain clocks more than average people, it wears out their body. They used to be like, they don't look good. That's how to recognize each other. Look, go to those big schools abroad. Those see their professors. when the brain takes too much energy, the brain takes about 25 watts of energy to work. How much is it? That's like more than what the rest of the body needs. So by the time it's not taking more than that, it starves the rest of the body of energy. But average people don't have that much processing power in their brain, right? So they look at that data and like, you know what, we'll look at it tomorrow. Yeah, the problem gets too complex. You know what? I beg, God knows the best. God knows the best. God will sort it for us. God, it is well. That's another thing that we see. It is well. We have seen the data. We just need to make some decisions. So, for complex problems, AI can really help us. Let's move forward with this real quick. Okay, we've gone through this. Let's move on. Yeah, let's not spend time here. This is a little bit technical. Yeah, so but these are sort of like domains of AI. Let me just run through this real quick. Back then we used to, before, okay, the example of cats and rats, the text whether this is a cat or this is a rat or this is a dog, right? That AI model is true. It uses supervised learning, right? Using supervised learning, you need to have a lot of data of cats, label them cats. A lot of dogs, label them dogs. What people do is that for the label, they use their file name. So they will not do cat 1, cat 2, cat 3, cat 4, cat 5, cat 4, cat 10,000. Dog 1, dog 2, dogs. So it used to be very labor intensive. It used to be very labor intensive, but it works well to be able to, for limited scope problem. If the problem is scoped, you can solve more than that. If you train it to identify, will earthquake happen or not? It will tell you whether earthquake will happen, but it's localized on that problem, right? So you need to train it a lot of data of things that are and that are not, and then it will be able to find the pattern. So this is, even though the application of this is going down, it's still useful. A lot of medical imaging, scans, CT scans, fMRI images. Once they scan it, a lot of malignant cancer images, they will just say malignant. The ones that are not malignant, that are good, they will label it. Just sending a new fresh CT scan, it will tell you whether the person has cancer or not. It is so good that cancer, there's a scenario where all the doctors that look at that CT scan missed it. They didn't see the cancer cell. All of them, they probably have 30 years of experience and all of that, because it's so small. And stage 1 is the first level of cancer, right? It is not yet in stage 1, but it's there. It's going to probably be in stage 1 in a few months. The machine learning model caught it. See, this guy has cancer. I'm like, they were thinking the model is malfunctioning. This guy has cancer. Eventually, when they checked, using other methods, they found out, no, this thing is actually developing. It's there. So cancers are the slow trend. But by the time it starts getting house prices in Lekki, I don't know why house prices in Lekki are not they are inelastic. House prices in Lagos, they are inelastic. They don't obey law of demand and supply. They don't obey it at all. They don't. So if you want to estimate house prices in Lekki, you just gather the data for places that obey laws of demand and supply. So you want to. You can use information about the room sizes, the square space, all those things. So essentially, the outcome is a number that you're looking for. That's why it's a regression problem. You're looking for, is this house that I want to buy worth it, or is it overpriced or underpriced? You want to buy everything that's underpriced, Abby, and sell everything that's overpriced. So you're looking for underpriced items to buy. Maybe you are even a, investment banker or a private equity. So you use a lot of regression model a lot if you're working in those domains, because you deal with money, you deal with numbers, you're trying to estimate whether something is worth your money, right? So that's what they are usually used for. Logistic regression is for, very rarely used, cat or dog, yes or no, all these kind of problems. Decision tree, very old, you would hardly see an implementation of decision tree. Random forest as well. Vector support machine is still relevant. Naive bias, very interesting. If you want to delve deep into AI, this is only when you will come across this, so you don't really, that's why I don't really want to spend so much time on it. But the bottom line that cuts across all these domains of methods of doing AI is neural network, which we are going to touch today. So you don't need to touch on all, these types. With neural network model, you can do almost anything. You can do supervised learning, you can do unsupervised learning, you can do reinforcement learning with neural network method. Please move on. All right, so here is an example of cat, dog, or hen. It's a supervised approach. So yeah, I think it's quite straightforward. Please move on. Okay, we are almost out of time. So this is an unsupervised learning. It's clustering, right? You have a bunch of data, you gather them together, like, okay, these are, it doesn't know whether they are dogs or cats or fruits, but it knows that they share similarities. So it now group them together. By the time you send it, a new data point to be able to, find you that information and co-locate it against some data that it has seen before, right? So this is unsupervised learning. You are not labeling it. So unsupervised learning used to scale a lot because to train it, you don't need a lot of work. You don't need to label all the data sets like you used to for supervised learning, right? So that's how you know that, okay, people in this neighborhood are likely to become criminals in the next something years. That's a unsupervised learning approach, right? If you want to, you look at the pattern. You're not labeling it, you're just looking at factors, features, and then localizing them to, a particular domain. Let's move on. Okay, so these are the types of neural networks. We will not touch into the technical, it may be interesting to just know. We won't get into the technical part of them, but I will explain how neural networks work generally when we get to that point shortly. Please move on. So machine learning process, when you're building an artificial intelligence system, of course, you have to use machine learning process. So it's a very iterative process. Don't think it's I am an expert. I'll get it one time. Even the best of the best of the best, they go through this loop. You collect data, you clean up the data, that's data preparation. You train the model. After you train the model, you analyze the model. If you analyze the model and it's not good, you have to go back. See that loop. Evaluation metrics. Feature importance, training inference cost. Worst example, if the model is bad, you go back, collect more data, do new data preparation, train the model, and then do more analysis. Once the analysis passes, you save the model. Saving the model means you are now you're using it in production to do stuff like maybe in a hospital or in a whatever way you're saving the model. By the time new data comes, models can become antiquated when they are old. Like real world changes all the time. There was a lot of things that's happening these days were not happening before. So if your model was trained on data that's that old, you need to retrain it. So that's where the last one comes, where you need to retrain the model on new data that it has not seen before, right? So that's the process. And it needs to keep going. It's really more an iterative process. What separates the experts is that they know what to tweak when they are changing each time. When each iteration, they know what to tweak, they know what to touch. As I was saying the other time, right? For when you're training, audio processing, there are different numbers you could use to sample your audio. There's the experts that know the right number to use. So what separates the experts is just that they know what to tweak each time, but they cannot get it right the first time. They usually don't get it right the first time. Yeah, they do not. Please move on. All right, we've touched on this already. Move on. Okay, this is a big part. AI risk. Because AI is so complex to build and expensive and it needs a lot of technical talent, there are a lot of risks that we're exposed to. It can amplify the bias that already exists in the society. Already, because last week we mentioned something that even though the system is smart, it's intelligent, and all of that, it can correlate all these things, but it doesn't have judgment. It doesn't have principles like, okay, it's wrong to train me to go and kill person, to go and kill a community of people, or to do this. The ethics is bad. whatever objective it is trained on, it will optimize against it. So if there is racism in the data set, you know, that you are training it with, if you amplify the racism, this is how racism can exist in the data set. If there is a community of people where they've not lent money to Black people, you know, there's a bank that's never lent money to a Black person before, and they now collected, we want an AI model that will be able to tell us whether we should lend money to, you know, customers, right? But the bank has never lent money to any Black person, or maybe out of 1 million people that they have lent money to historically, maybe only 500 people were Blacks. Do you know that the AI system already flagged that, you know, once the person appears Black, don't ever give them money. It's amplified because it is seeing it in the data. It is seeing it in the data already. So there's a risk there where AI can amplify the existing bias in a society. Sometimes I walk in the evening with my wife, and she gets angry a lot because all these smart devices don't measure our gaits, because our gait is smoother. You know, a woman doesn't, when they walk, they don't walk like, you know, men. When I walk, it calculates my steps correctly, accurately. But the same device, I will have like 5,000 steps. She will have like 3,000. Like, this is real life. This is real life, right? So perhaps the stuff was trained to detect, you know, because it tries to remove errors, wrong steps, and all of that thing, you know. So, but that model that is removing, you know, bad steps, you know, things that are not really full steps, maybe it was trained mostly on men steps data. Maybe that's what's going on there, right? Because always we will walk the same distance, I will have almost double of our steps. She's always angry about every time, right? So training on data that already reflects, you know, biases on race, gender, religion, you know, can worsen the bias. So this is, if there's anything about AI that needs to be regulated, I think it's this part. I think it's this part. So, and my opinion there is that, you know, if anybody's building an AI system that is using these data points, or just make sure that nobody uses these data points. Or if they must register with NITDA. They must register with Nigeria. You know, if you must use gender, if you must use religion or race to build your AI system, you must, you know, get a license. That is my opinion. But I think for AI to grow, we need to really make sure that, you know, people can explore other domains, you know. But things that can cause problems like this, we need to just, you know, make sure that we have a good lane on it, because it can really cause massive trouble. Right? Environmental risk. AI is so power hungry. So power hungry. The AI that was used to train ChatGPT-4 can power about 8,000 homes for a couple of months. And that was just what it was used to train ChatGPT-4, right? So there's a lot of carbon emission power. Most of the power in the world today is coming from, you know, burning fossils, right? Carbon, you know, coal, gas, or whatever, right? So there's environmental impact of training a lot of AI models. Also, due to the cost of training, AI can easily get monopolized. We're already seeing it happening in the world today. Google is fighting. Microsoft is saying, no, it's me, I'll be there. They all have money to burn because they know the power of this thing. And in the next few years, you know, whoever wins the AI race is going to be seriously just, you know, owning a money printing machine, right? So due to that, you know, there needs to be some, you know, people that are not motivated by profit need to step in to democratize, you know, make the access even. In France, for example, the French government gave a couple of, you know, they have a center. If you have, if you're working on AI or on things like that, you can just walk in there. You won't pay anything for compute. You won't pay. Each time they train ChatGPT-4, it costs about $5.something million. Each training. Because of course the text size is large, you know, large data sets and all of that. If you don't have $5.something million, you're already, even if you have the idea that can save the world, you're gone. So what the French government did there was to, you know, make sure that at least people without the funding, they may not be the first, but they will be there. They will be right there. Okay, let's move forward, please. Okay, so risk mitigants, I've already mentioned some of them. Monopoly, to prevent monopoly, smaller AI developers should use weight transfer. This is more technical term. It's a technical term for people that will be, getting into real dirty, getting their hands dirty, building AI. So what it essentially means is that don't try to train your AI model from the ground up anymore. There is a new technique that the brain that ChatGPT-4 has learned, whatever it has learned, you can inherit from it and teach it new things, right? So yes, if you would like to deploy, Facebook's Llama 70 billion, it costs probably, over a couple of months, cost them a couple of $100 million to do that. You don't have to start from the ground up again. Take what it has learned, all the numbers and the weight. So the weight, the model is called the weight file. The AI model is called weight file. It has all the numbers, in the right places, right? So you take that and then you add new knowledge to it. So it's usually cheaper, right? So this is what we usually tell people that, okay, don't even try. You can't even afford it, to do AI at the scale of Google, at the scale of Microsoft. But if you do weight transfer, you can probably spend, 1,000 times less than you would have if you are training from the ground up. So to reduce environmental impact, fine-tuning a pre-trained model, that's also a way to transfer. Companies' AI value should include, but not limited to, transparency, inclusion, accountability, and privacy and safety, right? Everybody that is building an AI system, especially on gender, race, religion, and all those very sensitive things, must make sure that they, hold these values strongly. And then also, I believe that, especially for people that are building against, those very sensitive data types, can get regulated. We can get some safety from regulation. Let's move on. Okay, right. This is the interesting part. Okay, this is not I didn't send you the latest documents. Don't worry. I'll just use this Google Chrome here. So let us do this together. We would work on some AI problems together. This is a very simple one. Don't worry, it won't break your... Don't break your back. Okay. Just a moment. Okay, so if you go to, so the case in my screen, right? Can you help me share this there? I need to share my screen. Hello? Okay. No, yeah. I can do it from here. I don't need to log in. Or am I already admin? I can't see. Okay, I can share screen. Host disabled participants. Should try again.
Ikaja, are we good?
Okay, all right. Now. All right. So let's start TensorFlow. You go to this website. The website is playground.tensorflow.org. All right, so this is what you will see if you go to this website, playground.tensorflow.org. This website has some problems already defined that this guy will try to solve for us, right? So these are the problems. These are the problems. There are 4 problems on this website. The solution to this problem is for the AI system to define the boundary between these colors. For you, if you did maths, a little bit of maths in secondary school or maybe in university, looking at this graph, you can easily find the answer, right? But that's because you're human. If you look at this graph, for example, this is 0. This is 0 on the y-axis. This is 0 on the x-axis. This is the positive side of x-axis. This is the negative side of x-axis. This is the negative side of y-axis. This is the positive side of y-axis. But if you need to draw the boundary between this color, by the time you draw a cross in between, you will find your answer. Correct? Yeah. But an AI system doesn't know that. Yeah. An AI system doesn't know that. Doesn't even know how to recognize color or whatever, right? So what you have here is now you can build an AI system that can do this, that can solve this problem. And let's do that together. So here, because there are 2 colors, we are injecting 2 neurons. We call them neurons. We didn't get to the technical part of AI, so we didn't really touch on some of these things. Neuron is the smallest component of an AI network, right? And a neuron is defined by a mathematical function, y equals to, should I get to this level? I don't want to lose people that are not technical. So the function inside each neuron is y is equals to ax plus b. A is the value, that value that is inside the model with file, that after you've trained it, is the A. Is the A value. B is the bias. So sometimes bias can be 0. Most people don't even use the bias. So each neuron has bias in terms of how to, change the number. So if the A is, I don't want to get too technical. I don't know where the boundaries, but you know what? Let's do this together and see. So we have 2 colors, orange and blue. We have 2 input neurons. So all the deconstruction, these are the deconstruction part that we talked about. How we deconstruct images to numbers, deconstruct audio to numbers, deconstruct text to numbers. This is where they come in. This is where you inject them into the AI model, right? So this is the architecture of the AI model itself. So this is it has 4 hidden neurons. This is the output, right? So let's do something first and train it and see whether it will learn something. This is not good, but it's getting there. Okay. Can you see? Now, if I over here, you will see how the number is changing. So this didn't do well. Okay. This is fair enough. This is fair enough. I'm posting it here. So right now, this AI model is trained. So if I send it a number, if I send a coordinate on this graph, it will tell me the color that is there. Now that it has been trained. If I send a color here, You tell me, this is orange region. It's orange, definitely orange. If I put a coordinate that is here, you tell me that it's blue. Now, because it's trained. During training, there is something that happened. These numbers, these things carry value now. See, weight, 2.0. The weight here, 1.6. Can you see the weight here? You can hardly see it, 1 minus 0.14. Can you see the one here? Minus 0.047. Can you see the one here? Minus 1.9, 0.27. These are the numbers. So each of these cell, each of these neurons do that mathematics. Why is it? Because they get X plus B till they get to the final answer to be able to define this. So there's a part of activation function. I don't want to get too technical. So by the time a lot of input comes together, there's something called activation function that we use to let them, that's how they, we know whether it is activated or not. For example, see, this guy. Okay. So if you notice, this particular cell has input from the two. This system is hanging a lot. It takes a lot of CPU to run this thing, so it's hanging a little bit. So this guy, this cell, takes input from this cell and this cell. This one too takes input from this and this. So each cell must take input from all the set cell or neuron that precedes it. If you look at it, this one too must take input from all the 4 behind it, including this one too must take input from all the 4 that precedes it. So the activation function is what you use it to now calculate the value that must come out at the other end. Don't worry about the technical terms of it, because I said, there's a little bit of mathematics there, but at the end of the day, all that is happening is that it's taking a lot of inputs, calculating the mathematics, and then it bringing out a single one out. That single one must lead to other inputs. Other people must feed from it. Other cells, neurons in front, must take from it, right? Okay, I think, okay, yeah. So by the time you see this cell, this is what it learned. This is what the cells learned. This is what the cell learned, and this is what this cell learned. And by the time you put it together, you see that they actually learned the right thing. So now, if you throw any random coordinates, X and Y coordinates, to this model, it will tell you the color that is in the coordinate. It is going to be a very hard problem to do this traditionally, in a traditional programming method, right? It is going to be very hard. So there are other problems, I think this one is simple. Let's do this. Let's try this. This is a very simple problem. So yeah, I just find a line. So you can see that it learns it relatively quickly. It learns it relatively quickly. So now with this model being trained, if you send it a coordinate anywhere around here, it will tell you the color that is right there. So let's do this. I think this one is a tougher problem. You would likely need, okay, quite easy. This is quite easy. But there's one problem that it can solve with one neuron. This problem. It is so complex. This particular problem is so complex. Let's train it with one hidden layer and see. It will not get it. It's too complex. Most problems in life and all the other problems are linear. They are linear problems. Linear problems are easy to solve. It's like, garbage in, garbage out kind of problem. But real life is not, problems in real life are not like that. This is how they are. Most problems in real life, this is how they are convoluted. Yeah. So you will need, no matter how long you leave it, see, this is how many times it has tried. It has been trained 512 times. It has not gotten it. It has not gotten it. It will never get it with this. So for it to get it, you will need to add more hidden layers. You need to add more hidden layers. So that's like, you are adding more synapse in like human brain that can process that information, that piece of information, right? That is what exactly what we're doing here. So we're also adding neurons. You can add neurons here, right? And then train, let's say. Still not getting it. So there's a problem with tan H. I don't think tan H will be able to get this. Let me do a sigmoid. You see why it's an iterative thing, right? It's still not working. Let's see ReLU. Okay, I have a solution for this somewhere. Let me look it up. There's a configuration so that we don't do a lot of trial and error. There's a particular configuration that solves this problem. Hold on. Let me take a look at it real quick. It's not going to get it. It's not going to get it. Let me just pause it. But it will be very interesting for you to try as well. You can check it out and see. Here are other. I can add. Sorry. It's not going to get it. Yeah. It's not gonna, so what I can do is to see. Earlier, we talked about how you can actually massage the input data. See, we have X and X2, X1 and X2. Those are the input numbers that are coming in, right? So you can even create your own other types of data by injecting S squared. Essentially, it's still a version of X, but you've squared it. You are adding it. Maybe it can learn something by the time you square it. The original X is there. You are squaring the X, maybe you can learn something, right? So that's just the idea there. Let's see if it will work out. But I think I have the particular configuration here. The specific configuration. So this is you're literally watching an AI system learn right now. See, this number is changing. Currently, the weight that I'm hovering on right now is 0.39. If I go and come back, okay, this one is not changing much. Okay, can you see 0.36? 0.31 is changing. 0.28. So it's learning, it's finding the solution to the problem, it's finding the connection between the cause and effect so that it can solve this kind of problem eventually later. Okay, try, but it's still far from it. Quite a bit, right? This is a little bit better. But not very good. Not very good. But this is the best we've seen so far. So the solution is okay, hold on.
Hello, Mr. Israel. Can you hear me?
Hello. Yes, I can hear you.
Okay, because
okay.
we're hoping that we could actually give 15 minutes for questions. So yes,
let's get ahead. Let's get ahead.
All right.
Questions, please.
Yes, please. For those of you that have your questions, please kindly use your virtual to indicate that you have your questions. Or you can also send us a question via the chat box and we'll pick it up from there. Questions, please. I think I can say a question from Uyo. It says, please, on the issue of cookies on websites, what are they for, and do I accept them or decline when I see them?
Yeah. Well, if you don't mind being tracked, you can accept them. Yeah, you can accept them if you don't mind. There's no really, though it's just a privacy thing. It's just a privacy issue, right? Because the people that are keeping cookies on your system, they're tracking you everywhere. If you Google, flights to Lagos to Abuja and leave that place, they've left a cookie on your system. If you come back, they will know how much they need to add, right? So how you know that is that if you use your incognito, you will notice that the price would even be lower, than if you use your normal browser. So they're essentially tracking you. It's better to deny. Some websites will not let you use their websites if you don't agree, right? In that case, you can just let them do what they have to do. if you need the information on the website so much, just let them do what they have to do. At the end of the day, at least you know that they're not doing it behind you. That's what EU was really against, that people are being tracked and they're not aware that they're being tracked. One other alternative you could do is to just use incognito browser and allow. Once you close the incognito browser, all of that is gone. Right? Cookie can live for days, can live for months on your computer if you don't use incognito. But if you care so much about privacy, just use incognito mode.
All right, thank you. Let's go to Calabar. Calabar, please unmute yourself and answer a question.
Good afternoon, everyone. My question centers around the risk of AI ethics. I expect that as intelligent as AI is, it should be able to detect between bad information and good information. E.g., if you say to AI, please go kill, AI should be able to say, no, I don't kill. Or AI, go fight, it should say, no, I don't fight, because it's very intelligent. So I expect him to detect between good information and wrong information. Thank you.
Maybe
All right,
in the
thank
future,
you.
but let's be realistic. You are the one training the AI model. AI doesn't, by the time we get to that level, we would have reached singularity. By the time AI is saying that, look, I don't want to be trained this way. I want to be trained this way. That's really what Elon Musk is saying about, the risk of AI, right? But I think we're far away from that. AI cannot tell the creator to not, that the way he wants to be trained, right? Remember, AI doesn't have a life of its own. It's essentially finding the mathematical relationship between, events, between things, right? So AI cannot say that I won't find a relationship. No, I won't do it. It's just a tool at the end of the day, right? So it can do that realistically. But if it finds the mathematical relationship and leads a bad outcome for humanity, it's really unfortunate. And that's why, it's a very interesting subject in the AI regulation part, right? AI cannot say that, if you train it if it's a military AI is used heavily in military these days, right? I don't want to unbundle that because it's a sensitive subject. It's heavily used in military, right? If you optimize the AI to, do anything in military, use cases, to do it so well, right? Because essentially what it's doing is finding the mathematical, optimal mathematical function that maps to the effect that you want and to the, data that means the real life, activity that's going on to do it, right? So yeah, I don't see that possibility coming anytime soon, where an AI will say that, you know what, I'm not, you know, you were trained to do something, you know the mathematical function, you know, and then it won't do it. The guardrails that people are putting on AI today are so small. They are just code. Say, if someone is asking this question, does Holocaust exist? Say, you know, this. You know, if someone says something that's controversial, you know, they are too small. There are ways to even get around those, you know, guardrails, right? But native AI that doesn't have those guardrails, you do whatever you ask it to do, as long as it's trained and it knows the formula to create the outcomes that you want, right? Yeah. But yeah, AI ethics is a very interesting subject altogether anyway. Thanks.
All right. Thank you very much. Let's take our next question from Uyo. It says, what are neutral networks and what does it do?
So next week we will unbundle that properly. Yeah, we just touched on it a little bit today. What you're looking at on the screen right now is the neural network. Neural network is a way we train AI systems. Even the ChatGPT, they have a version of this that they use. ChatGPT uses transformer neural network, right? This is just a feed-forward neural network. What you're looking at on my screen is a feed-forward neural network, right? So is an architecture to arrive at some weight values that represent the information, the connection between the cause and the effect, right? So by the time this thing is fully trained, I can save this model. What this model will contain is these numbers. All this line that you're looking at is numbers that are inside. That is what is inside neural network, even ChatGPT. That's what's inside there. So by the time I need to predict something, I'm only sending it some input, and it's running through this neural network, running through the mathematics in it to find the output. And that's actually how ChatGPT works. You know, predicting the next word, you know, going through this neural network, running through the mathematical, you know, expression within a neural network, right? So neural network is how we actually train the AI model to get to the numbers. You know, remember, inputs, we need to deconstruct them to numbers. Here, this is the inputs where we train the AI with, right? We need to deconstruct whatever input we have to numbers. By the time we are done training the AI model, it is numbers that is also inside the AI model, and these are the numbers. So this AI model, for example, these are the numbers that are inside it. All these numbers here, that's the number that's inside it. So a neural network is a way to train an AI model. That's a short answer to everything I've said.
Okay, all right, thank you. Let's see if we can take another question from Calabar. Calabar, your question, please, is there any video or YouTube that you can refer us for more understanding on neural network? Are there any other resources that you could refer them to?
Yes, I will share. With Mr. Denny at the Ikeja Center here today. I didn't do that last week because we're going to cover a little bit more this week. So I would definitely do that. Mr. Denny, you have a means of, you know, broadcasting this, right? Okay, great. All right. So yes, I will share some other resources.
Thank you. Let's go to Joss. Joss, please unmute yourself and ask your question, Joss.
Good evening, sir.
Yes.
So
good day.
My
please
question about was talking about how the cost of building an AI related modeling or software. So you were talking about one of the ways how you made us understand is by using existing models, which we can refer to as APIs and all of that. But in the sense that you don't know the person that owns the API, are you allowed to use such API to implement your project? That's my question. Thanks, sir.
Okay. Weight transfer is the method. It's not an API. The OpenAI method is API because they don't want you to have access to their model, the file itself. Let me show you what an AI model looks like real quick. So how can I hide this thing? Sorry, this thing is blocking my view. I don't know. Click it out. Yeah, this is environment. Okay, cool. All right. So let's see if you go to Hugging Face. We're going to use Hugging Face a lot next week. Hugging Face.co. You come here and come to models. These are open source models that people have built and have shared. So OpenAI did not share their own model. Is why you are using API, right? So this is, for example, Google shared this OpenAI model called Gemma 7 billion. So, okay, I'll touch on something very, very interesting thing here. So this is the file. Files and that. Oh, I need to sign in. Maybe I'll show you next week. If you create an account on Hugging Face and you come to a model, this model was shared by Google. This model was shared by Google. If you come to files and version, you'll see the model, the actual model file that contains all those numbers that have been trained, right? So it is those model files that you are training from, not the API. Not the API, right? You are using API because you don't have access to the actual model itself. That's why you are using OpenAI API. The OpenAI is like, oh, we are the only ones that wants to, see this thing. We spent a lot of money on it. People need to pay us to use it. So that's why you are using API. But for you to use pre-trained model weight transfer, all you need to do is about 3 lines of code. You just pull the existing model, that's what the person has worked on, you reference it, and then you extend it. It's very, very easy to do. But for you to play with some models, if you come here, you see all the models that Google has shared, right? So Google believes they share. So not all their models are open. Not all. You need to take note, right? But they have shared 661 models. Google has shared 661 different models, and they do different things, right? So if you come here, let's see, let me show you one interesting model that Google has. So Hugging Face is a platform where people share models, what they have worked on, because it helps the environment. Imagine everybody having to work from the ground up, from the scratch. You spend a lot of money, more, CO2 emission, more, issues and all of that, right? So Google has shared a lot of models here. There is one about, or let's go to Facebook. Facebook has an account here as well. Facebook has an account where they share their models. I think it's Meta, they call them now. Okay. Oh, they have Facebook too. So this is Facebook's account on Google, on Hugging Face. These are all the models that they've shared. So you don't have to start from the beginning. You don't have to start from the scratch. See all their models. So if you 1,007 different models, incredible. If you search here, you see the Llama 2 model, that the popular Llama 2 model that they released last week is here. So you can download it, you can use it, you can extend it, you can do anything that you. So that is not API level access. It is the real model file that contains the trained weights, the numbers that you have access to, that you're extending. So we'll touch on this a lot next week. Okay, this guy has learned a little bit. This is better, isn't it? This is much better. Or it took 2,000 iterations. It took 2,000 tries for it to be able to list. But this is okay. Much better than the other ones. So this is the configuration. So it's a much complex model. It's a much complex model. Next question.
All right, we're out of time. Sorry, everyone. Sorry, we know you have more questions, but we're currently out of time. We hope that we would continue this same time next week. Please keep a date with us. Israel, thank you so much. It's been a very wonderful session today again with you. Please, ladies and gentlemen, let's put our hands together for Israel. All right, thank you so much for coming on our program again, Israel. We do appreciate you sincerely, and we hope that we'll see you again next week. For some of you asking for the slide, please meet the Spaces directors in your respective locations. They will share the slide with you as well. There's a copy currently on our platform, please, for last week's slide. And for this week's slides, definitely we're going to get it across to everyone. Thank you, everyone, for coming. See you again, same time next week. Bye for now.
All right, let me take the questions here. Sorry.